The final little bit. Now let's go through our game quick so we can get it to YouTube. Our singleton pattern. What is a singleton? A singleton is just saying that we can only have one of these in the entire program. When I run my game, if I have 46 different objects that are game manager, only one will live, and that's the first one to run. And that is just, well, hopefully this script, hopefully we don't have another one. But if we do, we have this little wake trigger. And then the next thing we need to talk about, what a singleton is, just having one. Finite state machine. This is controls our game states. That's all this is going to do. Is it's going to have a reset the game, a quit, and it's going to control our buttons. It's going to control each time everything that turns on and off. This is everything. It doesn't actually reset the game. It resets the screen, but. And then we have our game manager has an up-to-date list. It has one, which is our alarms. Those do come into play later, and we'll talk about them later when it comes to doing the AIs. Pawn controller with inheritance and describe that. So our pawn is this guy right here. Every pawn will have all of these behaviors. This is an abstract class, meaning it will not go on anything. And then we have our player pawn. This is what the game object that you are controlling has on it, that just has a bunch of code there so that the character is working. The controller is there to grab your inputs and tell the pawn. It is a middleman. We want this middleman so that things don't get too complicated and that its bugs hopefully appear less. And then we are going to and how we can create it. How we create it is I'm gonna redo it so we get full credit. To create it, we basically get a script that its whole job is gonna grab every movement ever. Our moving, our crouch, our interact, all of it will have that. And then the next is our pawn, which is gonna get these, and it's gonna grab them from the controller, and then it's gonna do those actions. We have our CEO, which is the player, giving it to the manager of their pawn, the controller, and then finally the man who's making it all happen gets the information. Now, object-oriented programming. Kind of touched on a little bit, but I have one object, I have a pawn. This has all of the, what would you call it? The behaviors that our pawn objects will have. Every single pawn will, for sure, have a move. And it will have all of these variables because they're important to every pawn. Well, I should say most pawns. This did not get implemented. It did not implemented to the way that it just didn't fit. It happens. But our pawn AI uses our move somewhere in here, right here, has a move. And same with our pawn player also has a move. Now, where it differs is that we have a few different things in both. That's why they're not the exact same, but they're pretty freaking close. Game uses a timer. I do have a timer. I can never find it without searching it up. So this is it. Okay, so it is just looking for the time to move, and then this is just updating the time when we get to the thing before we go to idle. It just says, here's the time. Very simple. It saves a place, and it's waiting to see, are we there yet? Are we there yet? Are we there yet? Are we there yet? And then we're good. And then once we're there, we're like, okay, cool, we're there. Now let's do the thing. The game has a start and game over screens. I'm a man of having both two different win and loss screens. Personally, it makes me less complicated. So we'll turn off our gameplay, and we will. So we have our start screen. It's right here. Nice, simple, easy. And then we get into the menu, which means we have to turn off the start screen. We have to turn on the menu. We have our menu. Right, the first one, it's got our start, your credits, your option, your quits, and then we have our credits, which is those are the start screens. Then we have our win and lose screens. We have our loss, and we have our win. I'm gonna turn off the lose screen, and our win screen. Both of them kind of do the same thing, which is just you either quit or you go to the menu. There's no in between. World space and screen space overlays. It does have those. We can start. So if we start. We have up at the top left is our screen space. So this is on our screen. This is on the camera. The closer we get to the object. And then we have world space, which are these. They're attached to an object. Now, for the love of God, stop it. Okay, you're going over there. That was that. Also, the music's in there. Rectangle transform works. We'll restart this. Starting from the bottom, rec transform values, how they work is it basically is a rectangle that can be positioned just anywhere in the world in relation to whatever it's attached to, hence the canvas. These are just the values that are in relation to our canvas. The next one is pivots. Pivots just point to an object's thing. It's a point in an area which all these values are calculated. The x, your y, your width, your height, all of that is calculated, and that's kind of the pivots. And then finally, the anchor is just where it's attached to on the plane. Is a bad word to say that. It's just it's these are the easiest way to show them. Is like if I were to put it up here. I did not want to do that. I did not want to do that. If I were to attach it up in the top left, it disappears because it's up in the top. It's adjusted to the top right of the screen. When I put it back, you can kind of see when I adjust it on this side, it goes down in relation to this side. But if I were to change it here, once it's full size, once we're in the right area, it's going to go into relationship of this left corner where that is. It's going to adjust its space on the screen. One camera setting, no. AI seek, flee, patrol, and steering. So I have different names for these. Seek, which is controlled by this. Kachiga. Nice and easy, and it tells us the direction that we're going, and it rotates, and then its position is going to move towards that position. That is the only way this could work within the context of the game. The patrol is going to find the values that I give it, and then it is going to move to those values. This one uses the move vector too, right here. What's the other one? And then the flee is a sound alarm, which one of them has, and this is kind of important to the alarms we were talking about. So instead of fleeing from the player when it gets hit, because there is no health, it instead, once it sees the player, it runs to the closest alarm. Hearing and vision is here. Can see and can hear, and we use it in our finite state machine, not the player, the get player. When we check if we can see, if we can hear, or if we can't see and can't hear. Two personalities. We do have two personalities. Though that is the get player and the get alarm, I think is what I named the other one. That I don't have up, so I have to go get the code. Project. In our AI thing, get button. Get button. So I have my two different little guys. What they do is one will go towards the player, and that's how you lose the game. The other one goes to an alarm, and that's how you lose the game. They have that for a reason. The get players are a little bit more simple to get out of. You have some wiggle room if you get seen by them. The get button, you have no wiggle room. As soon as they see you, they're hitting that alarm button, and you'll hear your intruder alert, and then the game will end. It also allows you to finish the game before it ends. So if you happen to get, if there happens to be an alarm guy within the way of you getting to the end, and you have the Lotus, and you can get to the end just before it finishes the second intruder alert, you win the game. So there's a few ways why it's like that. Game uses a trigger. It does use triggers. It uses quite a bit. The easiest, I think, is in my alarm code. But I may not have that open, and I don't want to go get it open. So the door has one too. On trigger, enter. So when it is entered, it's able to be interacted with. This is part of a bigger code, which is the interactable code. Anything that you can touch must have an interact, an on trigger enter, and an on trigger exit. All of them do different things, but they search for a specific pawn. These ones don't, because none of the other pawns are going to go for them. But our alarm button searches specifically for the AI alarm, for the AI pawn. Game uses sound tools. It does. So I am just going to go and find in here in audio, whatever the first one. This one should be fine. This is in the player. This one uses one by the play and stop for our walking. The other one is dot, what is it? Play clip. Yeah, play clip. No, not open. Okay. Okay, it's in that alarm code, which I will have to go get now. I just don't seem to have it open. The button, that's why it's different. The button code. It just tells me when the button's pressed, most importantly. Does that just play? Game use, oh, it just says use them. Yeah, they all play. The other idea was to, some of them, like the button plays from the point, but it's not dying, so I don't need to play it at a point. It'll just play it, and then it'll stop it. And in the buttons, there are 3D sounds. Yep, they're 3Ds. So that you can kind of hear them. You can't hear them 100% of the time. If you're far enough away, you won't be able to hear them. But in general, you'll be able to hear them. Time delta time, it does use that for our movement. Time dot delta time player. It just makes everything time dot delta time when we move, when we have that new position. This is just to make everything work within real time and not based off of our frame rates. Otherwise, if I was them, I would set my frame rate to a bajillion to move through faster than the system can update. And then it uses rigid body move dot position. Oh, literally right next to it, right here. So what this code does specifically is it gets where we are looking. Well, it gets a vector. It's given a vector specifically for the move player. It is given a vector which is adjusted by the camera's position in our controller. It is given the vector, and it's given the move speed in the pawn from the pawn, and then it gives it back it doesn't give it back. It gives it as a rigid body. It tells the rigid body, I need you to move to this position. And then it adjusts our move speed based off of if we are crouching or not, and it is a fraction to crouch, which is nice for me. Setting for sure. Our gravity's used. We don't actually shoot anything, so force isn't used, but we can look on our player. These are the first thing. Our rigid body, they all use gravity, so they make sure they fall, and they're not just kind of floating in the sky, floating about. And uses rotate. Transform.rotation. It's just setting our rotation to the look direction, our Quantanian look direction. Quant something or other, however you say it. Same kind of concept. It just doesn't use the exact rotate. It's just making our rotation as we are slowly looking towards something. Just hurting us slowly. And got a bunch more. Our get key downs. We don't, our get key inputs. We don't use the get keys in this project because of the new. It is in edit project settings. The input system, which I feel like is a little bit easier to use, especially when you're doing a bunch of animations. So all of these are able to be adjusted. They're right here. If a designer can't figure this out, they shouldn't be a designer. But we have our sprint, you have our move, you have the look. All of it's here. The look isn't necessary for this one, but if we were on controller, we had a look. And it has it in as a 2D value vector, and then it's going to give us a 2D value vector back based off of W, A, S, and D. Our forwards, our backwards is X, and left and right is Y, in the vector at least, and it's going to give you a number based off of that. So if you're pressing down S and A, it's going to give -1, -1, and W is 1, D is 1. So it allows us to have a better movement rather than just the get key down. Initial instantiated prefab. I do have this. This is in our manager, and this is on the reset of the game, which is specifically for our Lotus. Our Lotus destroys itself, so we instantiate it back when we reset the game, and then our Diamond Interact destroys it right here. Our Lotus. They're named somewhat consistently. I just call it for the game itself. When you're playing the game, it's a Lotus, but all in the code is called a Diamond, just in case we decide to change the image. For loops. Yes, I have a for loop. It is in our controller. AI. When we are doing the patrol. Not when we're doing the patrol. I have a few of... There it is. It is for the sound alarm. Not the patrol. Sound alarm. It is going to go for each instance of the sound alarm within our game manager. We are going to get we are going to get the first one. If it exists, it is going to be set to the closest alarm when we are in the first one. Else, it is going to look from a current position to our new position is from the next alarm from whatever it's finding our enemy to the next alarm, and it's going to get that position. If it is shorter than the other, then the one that we already have as our closest alarm, it is going to replace it as closest alarm. Otherwise, it's going to go and do it again. And it's going to go through the 3 that we have, so it's going to do it twice. And that's kind of how it works. It's just going to say int I equals 0, is we're going to start at the index of 0, and then for each index of the length of the alarm array, we are going to go through and do this code. Very simple. That's the for loop. And then we need to explain ints. An int is an integer. It is a single whole number. A float is my personal favorite. It is a number that uses a decimal point, but is not a double that is just a decimal point. A string is a list of characters. Specific. I'm not like saying that isn't like it uses the data type of character char, and then we have lists. Lists are kind of like arrays, except they're dynamic and that we can constantly add to them without initializing them in the beginning. And then classes are these. They are groups of scripts or code that falls under a name that runs a bunch of codes. So this is a class that holds the code of the class, of the thing, of the object.